Hello everyone, nice to meet you all. My name is Alex Garcia. Today I'll be talking about how you can use the command line in your data visualization work. Now the command line is a central tool for software engineers around the world, and in this talk you'll learn about some specific tools and strategies that you can use to speed up your data wrangling processes, optimize your data visualizations, and automate your work. A little bit about me, I've been a freelance software engineer since January of last year. In my work, I typically focus on data visualizations, developer tools, and just general data processing. I really like working with D3, JavaScript, and Observable notebooks. I stick to SQLite and most recently DuckDB for data processing. I like to build command line tools with Go, Node.js, and Python. Now, combining two of my favorite things, data visualization and the command line, we get this talk. Now, I'll be the first to tell you that the command line is for everyone, not just for software engineers. If you work on a computer, then the command line will be useful to you. There is a steep learning curve, just like learning a new programming language or learning new software, but it will be worth it in the end. Now, in popular culture, when you see a command line like this, it's usually accompanied with some hacker in a hoodie in a basement trying to get FBI files. But don't be intimidated, you can style your terminal to whatever color scheme you want, and you should make it yours. Now, my favorite depiction of the command line in popular culture comes from the Oscar-nominated 2014 film Teenage Mutant Ninja Turtles. In the final battle scene, this happens.
You know how to use this thing? It's a single command line interface. No one's used this code in 15 years. I mean, I read about it online, but this kind of thing takes time.
And just to get terminology straight, whether it's from this talk or from other conversations you had with other people, the command line, the terminal, command prompt, shell, these are all mostly interchangeable words, and they're probably referring to the same thing, which is the command line. And if you're wondering why people or why software engineers tend to prefer command line tools, it's because they process data more efficiently than desktop or web applications. They typically use less resources like your CPU and RAM and memory, and small command line tools can be pieced together to solve bigger problems. And here's an example that shows why command line tools are usually preferable to desktop or web applications. Here I have a fairly large CSV file. This is 53 megabytes from the LA Times dealing with COVID data in California. Now, if I wanted to preview the CSV to see what type of data it has, how many columns or rows it has, what I would do here with a Mac is I would just simply click on it. In Mac, this will boot up the default Numbers application, which is very similar to Excel. And this is going to take a very long time. Right now, I could already hear my computer heating up. The fan is speeding very loud. Soon enough, I'm going to get the little beach ball of death of rainbow thing swirling around. So this is a very slow process, usually trying to use the default GUI system that exists on my computer for a data set that's not even that large. So just so you know, after I tried opening that CSV file, my computer froze up. It gave me this error message. So the Numbers program just kind of like blew up and didn't work at all. And when I did finally get it to work in the Numbers program, it didn't even parse the CSV correctly. So here in this Numbers spreadsheet program, the data's everywhere, the columns are messy, data didn't line up. So overall, not a great experience using the standard built-in GUI applications. Now let's take a look at a few tools you could use on the terminal to preview that same CSV file in a much faster way. As you can see, I'm in my terminal in the same directory as that large CSV file. We can confirm that yes, this is the same 51 megabyte file. If I just want to take a look at the first few lines of the file, I could use the head command, and this is instantaneously giving me the first 10 lines of that file. I could look at the columns, I could look at preview some of the data points. I could also use some other commands like CSV stat, where I could take a look at specifically the number of rows that are inside that file. And we can see that after a little bit, there are over 800,000 rows in this file. If you've never worked with the command line before, just know that your computer probably has a terminal built into it that you can access. Similar to how Microsoft Edge is the default browser for Windows or how Safari is the default for Macs, typically your computer will already have an application installed that you could use to access command line tools. For example, for Macs, that default is the terminal application. But if you want something a little bit better, iTerm2 is a very popular terminal client, as well as Kitty, which is the one that I personally use. If you're using a Linux computer, I'm assuming that you already know what you're doing, but there is a default terminal application that comes with those distributions. Now with Chromebooks, you can actually get a terminal. You can install Linux on your Chromebook. There's some guides on how to do that in a legit way through Google. This is actually what I did for 3 years out of my college, from sophomore year to senior year. I had a Chromebook, so I installed Linux on it. That's what I used to do all my homework assignments for my computer engineering courses. Windows has the default terminal application. It also has PowerShell, which is very popular among Windows users. There's also a new Windows terminal application that Microsoft has been developing for the past couple of years. And I'm going to play a small clip of when Microsoft first announced the Windows terminal. They created like this little commercial marketing video that's just hilarious to watch to see how they hype up like a terminal application. So I'll play a few seconds of that.
Watch what I do. I see you looking. Watch what I do. Oh my, oh my. Watch what I do.
Now I'm going to go over some command line tools that I recommend that I use in my data visualization or data processing work. There's a lot of tools I would love to recommend, but I only have so much time here in this talk. So I have a notebook here that lists over 100 command line tools that you could use in your data work. Now, if you like a tool and you don't see it in this list, feel free to fork the notebook, make a suggestion, and share it with everyone. First, I'm going to go over the 3 quintessential tools that I think you will probably use as your life as a data visualization practitioner. I'm going to go over these first just to ensure that if you're going to get anything from this talk, it should be these 3 tools because you'll most likely use them. Now, the first one is VisiData. VisiData is a tool that you could use to quickly explore a data set, whether it is a CSV file, JSON file, Excel, TSV, whatever. It doesn't even have to be a file. It could just be a URL that you fetch whenever you call it. It is a very versatile tool. I use it every single day, and here's a quick demo of how it works. So we're back on my terminal. We're going to take a look at the same LA Times CSV file that we were looking at before. To use VisiData, it is a command called VD, and you pass in the file of whatever data you want to look at, and it will load it into what looks like a large data frame. These are all the rows inside of the data set that we were looking at. I use the arrow keys to kind of go over to a specific row. And if I click enter, then I can see, more exact values from the row that I selected. I can also go over to a column, and if I hit Shift F, for example, I'll do that on the county column, it will make a histogram of the most common values inside of that column. So you can see down here, Los Angeles is, or right up here, Los Angeles is the most common value inside of this column. I can even hover over a place, so I can go to Orange County, hit enter, and now it's the data that's filtered only for Orange County for all the different rows inside this CSV. So there are many different keyboard shortcuts, a lot of different commands, macros, a ton of things you could do with VisiData. Next up, JQ and FX. These are 2 tools that help you explore JSON data. JQ being the older, more mature one, while FX is a newer one with a little bit more features, which I'll demo in a second. Now, these 2 tools for me have replaced what I used to do, which is Googling JSON viewer or JSON formatter every time I had a JSON blob that I wanted to inspect. And you would take that, you'd paste in some sketchy website, which is insecure. It didn't work that well. It didn't handle big data at all. And these 2 tools are much faster and all on the terminal. So we're back on the terminal where I have a JSON file called vehicles. It contains data of LA Metro buses and trains. And if I want to explore this with FX, all I have to do is just pass in FX in the name of the file. And this is an interactive way to look into the JSON data. So you can see there's a key called items. There's arrays here. I could actually click on these items. I could scroll through and click to see all the different sub items within. There's also a query language. So if I type out period items, and if I only want to look at the 100th element and then specifically the run ID attribute of the 100th element, it'll appear on my terminal right there. So what you could do with JQ is if you pipe it into JQ, it will pre-print it directly into your terminal if you just want to take a look at it. There's also a filtering language very similar to the one in FX, where if I want to look at all the items and only the run ID for every item, then it'll print out all the different run IDs for all the items. And from here, if I want to see how many items there are, I could do a word count of the number of lines in the output, and I'll see that there's 620 items within this JSON blob. Next up, the exact tool is going to be different depending on your operating system, but any tool that you could use to either read or write to your clipboard will help you out a lot. In macOS, this is PB copy and PB paste. Windows has its own little thing. Linux has a completely different system. But essentially, if you could pipe in data into your clipboard to write to it, or read from your clipboard to feed it into a program, this is something that I found that I use quite often. And here's an example. Now, some ways I use PB paste, which is the macOS utility to get data from your clipboard into the command line. For example, here I have some JSON data from some random census API. So if I go ahead and copy this and I go over to my terminal and I type out PB paste, I can see the same exact data that I copied. I can also pipe this into JQ, which we talked about before, to get a pre-output of the data that I had. And I can do the same thing as I did before with like FX if I wanted to like interactively go into the data itself. So that's how you can use PB paste. Now, PB copy is also very useful. So if I want to copy something into my clipboard, so for example, let's look at the same vehicles.json that we were looking at before and pipe that into JQ. What I want to do is I want to get this JSON data into a CSV in my clipboard, so that way I can paste it into Google Sheets, so I could have it in a spreadsheet and look at the data a little bit more. So what I could do with JQ is I could do some pre-processing to the data, where I'm only going to look at a few fields that I really care about, those being the vehicle route IDs, the ID of the vehicle itself, as well as the location of the vehicle, and a few more commands in order to massage the data in a way that I need. Finally, I'm going to convert this JSON data into a raw CSV, and you can see what that looks like right here. And now what I want to do is I want to get this data as a CSV into my clipboard. So I could just pipe that directly into PB copy. And now if I go over to a spreadsheet and I paste in the data that I have, and with this, I can split text into columns as a CSV, and there we go. So without having to write that JSON file into a CSV and then filter the rows through there, I can do it all in the command line. And instead of redirecting it to a file, I could redirect it directly to my clipboard. So that way I could paste it into spreadsheets or any other application that accepts raw text data. Now I'm going to recommend some tools for data visualization specifically. First off, tools that help you optimize data viz. If your published data visualizations are static SVGs you serve directly to readers, I recommend SVGO. SVGO will optimize SVGs by removing unnecessary numbers and simplifying complex geometries. You'll see a great reduction in file size, sometimes half or more. In a similar vein, if you distribute your data visualizations as images, ImageMagick can be used to convert between image files. You can convert PNGs to JPEGs or other lossy photo formats, and this will typically reduce file size significantly. If you work with maps or cartography, always remember to simplify and compress your shapefiles before you publish. MapShaper and Topo.json Simplify are both great tools for that. And as a general rule of thumb, if you have a go-to JPEG compressor or SVG optimizer website that you Google every single week, look into doing it on the command line instead. Save yourself some time. Next up, Puppeteer and Playwright are open source tools that you could use to automate an entire web browser. Now, Playwright specifically has a command line interface that you could use to pre-render your data visualizations. So for example, if you have a website that hosts your data visualization, and you just want to take a quick screenshot of it, instead of opening up your web browser, going to the website, clicking on things, and using a screen capture tool, instead, you could use Playwright to just directly call a screenshot command on your website, and it will open up a browser, take a screenshot, and save it as a file onto your disk, which is much faster. If you have a dashboard that you like to save as a PDF and you share that in an email, instead of opening up your web browser and going to the place and taking a screenshot or printing it as PDF, instead, you could use Playwright that has a PDF command that'll open up that website, save it as PDF, and download it to your file system. Also, if you just want to automate your daily tasks, there's a small tool called CodeGen, and this is an example of how it works. So what you do is, from the command line, you call this CodeGen command, and it will open up a web browser where whatever you do, record the code that you need in Playwright to automate that process. So in this example, we're opening up Wikipedia, and this person goes and types in specific terms in a search bar, and they click on buttons and they open up menus and all that. And you can see on the right-hand side, you can see the automatically generated code that's needed in order to perform those same tasks again. So again, all in the command line, a much easier way to automate your task using the web browser with this specific tool. Now, another tool that I recommend is Observable Pre-Render. This is a tool that I created for observable notebooks. If you don't know what observable notebooks are, it is a tool created by the creator of D3. It's a great way to prototype and build data visualizations inside of your browser. There's many different examples you could import from and use in your own work. And what Observable Pre-Render does is that it gives you access to these data visualizations in your command line. I have a blog post here that introduces what the command line interface to Observable Pre-Render is. And here's some demonstrations of how you could use Observable Pre-Render in some projects. So here's a notebook. This is a G3 bar chart, where in this notebook, there's a cell called chart down here. Now, if we wanted to pre-render this notebook and pre-render this cell specifically, what we would do on the terminal is call Observable Pre-Render. We pass in the name of the notebook, the cell that we want to render. In this case, I want to render it as a PNG. And what Observable Pre-Render will do is that it will render that notebook, render that chart cell specifically, and save it as a PNG file. So now I can see that I have a chart.png file inside of this directory. And if I open that file up, I can see that here is the rendered version of that chart cell. Now, since I have a special terminal, I have the Kitty terminal, there is an icat command where I print a picture inside my terminal. The way that I do that is if I instead redirect the output to stdout, and I pipe that directly into the icat command, then my terminal will print out the picture in my terminal, which is kind of a cool little fun thing to do. Now, an example of another notebook that we could do. Here is one of my favorite notebooks from Mike Bostock himself about the impact of vaccines from a vaccine that was released in the 60s, it looks like. So if I wanted to render this notebook as well, I could do the same exact thing. So observable pre-render, the name of the notebook, and I want to render the chart cell. I'm going to redirect the output to std out, so that way I could see it directly on the command line. I want a PNG, and it will render the notebook and print it out directly in my terminal right here. Now, I'm not just limited to what the notebook has by default. For example, here's another notebook. This is a light fork of another notebook that someone from Observable created that shows COVID cases in a specific state over time, from left to right in this time chart. Now, in the notebook itself, I could actually go and choose a specific state that I want to see, like Oregon or North Carolina. And I could also do this from the command line as well. So what I'll do is I'll take the name of the observable notebook and use that in observable pre-render. I want to render out the chart cell, pipe in the ICAT, and then I can see the rendered chart of that cell. But I could also go in and redefine specific cells. So for example, instead, if I want to look at a different state, if I just want to see California instead of the default of Washington, I could pass in this redefine flag here, and it'll give me the cases for California instead. There is also another cell called start. So instead of the start date being in, I believe, the beginning of 2020, if I want to look at it from 2021 until now, then I could pass in January 1st as a start date and see just a condensed view of what it's been like in the past year. I could also put in an end date. So if I just wanted to restrict it to just 2021 and not include the giant surge that's happening right now, I could do that as well. And again, this is all in the terminal, all pre-rendering in a legit web Chromium browser, but it's displayed in the terminal, and it's a much faster way to iterate on a notebook, inject my own data into it. I can redefine the colors, I can change the scale, I could do whatever I want from the terminal. And if I ever needed to go down into the data visualization itself, I can just quickly go back to my notebook, make changes, republish it, and it'll be accessible in observable pre-render inside my terminal. Now, some real-life projects where I've used observable pre-render. This is a project where I had an observable notebook that would render for every state in the United States the line where half of the population would live above or below. So in this example, on the left-hand side, half of California's population lives above the red line and half lives below it. Now, this notebook had a lot of calculations and rendering, but essentially I wanted to do the same thing with every single state in the United States. Now, doing this by hand in observable would have been kind of annoying, so instead I use observable pre-render to pre-render all 50 states through the command line to automate that process, made it a lot faster. And in this example, I had an observable notebook that would render for a given location on the globe how much sunlight that location would receive throughout the entire year. So on the right hand side here, you can see this is for Los Angeles, the amount of sunlight it gets in the year 2020. And in order to make this visualization, observable pre-render has this observable pre-render animate utility, which will generate frames for every single cell that you define. And then I use FFmpeg down here to stitch those frames together into an MP4 video. So these are just two commands that I ran on the command line to generate this video based off an observable notebook. Now, some parting advice that I will give to those of you who are new to the command line. Learning the command line can be challenging, but there are many free resources out there that will help. These are some of my favorite books and blog posts that I think are the friendliest towards people who work with data. Additionally, when you do start using the command line in your work, I recommend taking notes of the tools that you use and how you use them, which will be helpful later down the road when you share your work with others. And never be afraid to ask for help. Everyone who uses the command line today used to be in the exact position that you are in now. Now, for those of you who want to build command line tools, I recommend reading these guides that go over specific features and design patterns that will make your command line applications more friendly. I used to think the CLI apps that I wrote were nice, but after reading some of these guidelines, I realized there was a lot more that I could do to make them better. As always, try to make your tools work well with other tools, allow for users to input data from standard in, and give them the option to write to standard out. And finally, this final blog post has many tips and tricks on how to add JSON output to your command line tools. And that's all I got for today. I really hope you learned something cool in this talk. I would say that new knowledge typically doesn't stick around unless you actively try something new. So I challenge you to try a new command line tool today. It could be one from this presentation or one found in the 100 plus command line tools list in this notebook down below, or any other ones that you find. Just try to build a habit of it today. It could help out in the long run. Getting others involved help as well, so share a new tool with a friend or a coworker. If you're at Outlier, I'll be around to answer some questions right now. Otherwise, start a thread in the Topic Tools channel in the Data Viz Society Slack. If you want to chat, I'll be hanging around in there usually. So take care and have fun at Outlier.